Hello ladies and gentlemen, what is up? Trippy AK here again for another C++ tutorial, and before we begin I'm just going to clean up this small mess that I left. And that is all. Right now we're just going to be working the main because Sizeof is pretty simple. So when you think of Sizeof, you think of how much, correct? Like the size of a 16 ounce of Coca-Cola or Dr. Pepper, whatever. So Sizeof is the amount of bytes or data that a variable holds. So every time you make an integer called a or char name b, well, like my integers x, y, z, then this will be a, then double c b instead, float c, then bool d, and we'll just throw in a string really quick. String, and then string name. So we have 6 different variables, and they all contain a size, integer, char, all the way down this nice little line. They, when you call them or make them into your program, the computer sets aside a certain amount of memory. What I mean by that is that you could literally see how much space everything's taken up. So if you were to use the Sizeof method, Sizeof, and then say x, all you need to do is put in the variable, because this knows that it's a integer. We build and run, it'll give us 4. The reason why it gives us 4 is because it sets aside 4 bytes of memory aside in order to keep your computer from running out of memory. Now, when I get into pointers, you're going to see that we're going to be manipulating a lot of little things with variables, because every time I call this variable, it's gonna v, it's gonna print out 4 times. But what the computer is doing, it's making a copy. Like, I literally just Control-C, Control-V, copy and paste. That's what the computer does when it comes across the same instance or reference of this variable. Now, what about a char? Let's say a 1. Well, letters are much more simple because an integer could go negative or positive, while a character, there's only 25 characters in the English alphabet. 25 or 26, I don't really keep up with that, but somewhere around there. Then a double, let's say b. Now, if a double is a more precise type of decimal or integer, it should be larger, and it is. Let's see float, which is c. Pull and run, 4. Now, even though float is a decimal and integer is an integer, it still has the same amount of space because it's not very precise. Now, bool, which is d, is Boolean. I didn't really go over so much, but it's true or false, and that only has 1 byte. The reason why it only has 1 byte is because there's only 2 instances, true or false, or 1 and 0, true being 1, 0 being false, or on off. If you've done a little bit of computer science or know some things about computers and electronics, you should know that on, off, or high and low, but it doesn't really matter for this case. Now, string has 4 again, because even though they're characters, it's a string of characters, it's a literal array of letters. So right now, that's cool and all. You know some things about memory right at the moment, but let's say we have an array called alpha, and we don't exactly know how many items of, actual items there is in the array. So let's say we have another integer called x, and then we have just arbitrary numbers. We have 1, 2, 3, 4, 5, 6, 7. Let's make it 8. So 1, 2, 3, 4, 5, 6, 7, 8. Awesome. Now, as we've seen before, see out size of x. We build and run. We see 4. What about the size of alpha, which is an array that we don't really know because we're a programmer and we're making an application. Now, yes, the programmer should know that the size of or the memory that they're going to use, but you don't exactly know how much space is going to be taken up when a user uses the application. I mean, you could do 2 plus 2, or you could do the whole like summation of averaging, whatever, stuff like that. Really complex stuff. So we already know that our integer value is x, 4, and then we have 1, 2, 3, 4, 5, 6, 7, 8. We have 32 bytes dedicated to alpha because there are, I said 8, right? So, sorry, 8 different things. So 8 times 4 should equal 32, because 16 plus 16 equals 32, but whatever. So, let's say you don't know how many elements are within the array, and all you know is the size of 32. Well, you could go ahead and say that you wanted to find out number of elements in array. So all you need to do is size of the array, because that's the bigger number. I mean, you could probably figure it out. Alpha divided by size of x. So you're going to do 32 divided by 4, technically, pretty much, and you should get 8, because that's how many elements we have in the array. And we do get 8. So that's the very basics of the size of. I mean, you could go on and say, okay, whoop-de-doo, but this is more for memory management. As a software engineer, you need to worry about memory, because the more memory you have, the slower your computer's going to go. I mean, video game developers, not the designers, the developers have to worry about memory, because every time an enemy spawns, that is a whole lot of memory going on. I mean, you have millions of people on World of Warcraft going on and stuff like that, or Halo, and every time you leave an area from your machine, all those connections disappear. When you go from level to level, all those enemies, when they spawn, it's triggered by an event. They're not chilling there having some coffee all day. No, they are spawned and they disappear. And we'll get to that with pointers when I go over stack and heap. The next tutorial I will go over the while loop and the do while loop, because those are very simple and logical operators. For now, that is all for this tutorial.